These are the panels. I have a check valve there and a universal joint to disconnect the panels for winterization in the winter. Here in Maryland it gets pretty cold in the winter. Panels I previously bought from the pool supply companies would always freeze no matter how I tried to winterize them or blow them out. These are made out of irrigation 1/2-inch pipe. Each one of these sections is 20 foot long, so a 100-foot roll for about 25 bucks at Lowe's or an irrigation supply store will do one panel. The water comes up there, goes across to the other side. And these 5 pipes, there's a drain valve, and it goes up this pipe. There's a bleed valve here, bleed out air for the first time. And it goes back to the other side to another manifold, then up to there, then back over, then up to there, then back over, and so on. I've been working at this, trying different things for a couple years. This section here is made out of 1-inch CPVC with T's reducing down to 1/2 inch. I was just able to slide the irrigation hose over that and put hose clamps on it. I added 2 more panels this summer, and this I just used 3/4 inch PVC, regular PVC. Though I do think the CPVC is better. And like I said, you want to have universal joints and slip couplings so that in the wintertime you can open it up and drain the system fully. However, these lines don't crack even if you leave some water in them. Here's the top of the panels. You can see the water currently going through there is about 96 degrees. It's partly cloudy today, but still heating up the water about 6 degrees. All right, here's how the system works with very little added energy. Basically, I have a 12-volt adapter connected to a timer for the hours when there's sunlight on my north roof. My panels are on the north, even though it's not optimal, just because I didn't want them to be visible from the street. So between the hours of roughly 9 and 5 p.m., I have daylight hitting the panels. So this timer opens a valve, it's a low voltage irrigation valve here, at 9 a.m. and then when the timer shuts off, it closes the valve. So that's an old irrigation valve, and so the only added energy I'm using for my system is the 12-volt adapter. The water pressure to get the panels up to the roof comes from here. If you locate the connection between the pump and the filter, it's higher pressure here because of the resistance of the filter than it is here. So by locating it here, when the valve opens, there's enough extra pressure that it pushes it all the way up to the panels, up on the roof, through one of those pipes, and then it comes back in this pipe here, and then I have it going right back into the back of the return line via a T. Again, it's good. This is another check valve down here. It's good to use the check valves, and I have a hose in this particular connection here. It just makes winterization a lot easier. Pipes from the pump and going back to the return line come from here. At the top, I don't know if you can see there's a small air valve. It's the kind that you would use in a radiator system. It basically just automatically bleeds air out of the system on startup. Because of the way my roof was laid out, it made the most sense to run the pipes up that side of the house and then actually have them running in the gutter up to that point. There's the panels. Like I said, there's 6 total runs of 5 parallel pipes at 20 feet each, so 6 rolls of irrigation pipe.